So this time we're gonna solve a problem of rotating unbalance. So in order to find the response or the vibration amplitude when you actually have input from the rotating unbalance. So let us take a look at one of this example. So you have a rotating machine of mass m equals to 100 kilograms. So maybe this problem is a little bit easier, okay, because you already have all the values given in the form of variables. Okay, so I just list down all these variables. If you look at it, okay, you have your m, capital M, K, C, your omega. So make sure your omega here you already define it in terms of radian per second, and you have small m and E. Okay, so basically it's all given, so then it's easy for you. Then what you want to do is basically you have to here determine the amplitude of the vibration. So what it means by amplitude of vibration here, basically what you want to find is your capital X. So so let us do and start the solution. Okay, so remember we already have this equation in lecture 9, and you can also refer your textbook equation 3.80. So it's fairly easy. You just substitute into the equation with your ME. You can rearrange the terms. Okay, let us calculate first maybe your ME omega square. So sometimes it's good that you make it step by step so you don't make a mistake. So maybe I just want to show you what will you get for the numerator. So you have here your omega is 628.32 square. So for your ME omega square, if you calculate that, you should get 197.3930. Okay, then you calculate the numerator. So your numerator of K minus capital M omega square. So you will have your 50,000 minus your capital M is 100 times your omega is 628.32 square. So if you calculate that, you should get 39.4286 times 10 to the 6. Okay, that should be a negative here. Should be a negative. Then you can just substitute into the equation. So if you do that, I should have your capital X. Maybe if you go through, okay, sorry, we haven't calculated the C omega. If you calculate your C omega, okay, C omega square, you should get your C omega square is 98,000. Is such a big number here. 0.5056 times 10 to the 6. And then if you substitute everything, the numerator you should have 197.3930, and you have 39. Maybe you can double check all the numbers again. Times 10 to the 6. So your final answer should be 5.0062 times 10 to the minus 6 meter. Alright. Okay, so you have the final answer here. So it's fairly easy because In this case, you have all the variables given, so you can and they're just asking for the amplitude of vibration. Okay, so maybe we'll see you again in another example problem. Bye.